Today we're going to look at volumes of solid revolutions with washers. Okay, and first off, what is a washer? I don't know if you've ever seen one before, okay, but it's a round thing with a hole in the middle. Think of it as a donut, okay, like this. All right, and so we use washers when the region does not touch the axis of revolution. Now, like here, if I wanted to rotate this around the x-axis, this would touch all the way from here to here around the x-axis. So that would be a disc. But if I rotated this around the y-axis, if you notice up here, I would have a hole. Right here it touches, but when it comes up here and I rotate, and let me draw this on the other side, what I have is I have this hole that I have to subtract out. Okay, same thing here. Whether I rotate it around the x or the y-axis, say if I did it around the x, you'll notice that there would be a hole in here, right here, that I would have to subtract out. Okay, so the area of a washer would be pi, I'm going to say big R squared minus pi little r squared. Okay, and so if I factor out the pi, it's just big R squared minus little r squared. And what we mean by big R is the outside radius. Okay, and it's like the top curve minus the bottom curve. And the little of the big bottom. Okay, and then the little r would be, and think about this as the inside radius. It would be the top curve, and I'm doing little top, minus the little bottom curve. All right, so we're going to see this and find the volume. And we'll integrate it the same way like we did for the disc. All right, so let's look at number 1. We want the volume bounded by the square root of x and y equals x squared. So if we're looking at that right there, okay, here the square root of x would be 1. All right, okay, at 2, or no, at 4 it's at 2, so I'll do that. Okay, so it's looking something like this. All right, here x squared, that would be at 0, and then at 1 like that, and it goes up like this. So really we're looking at this little sliver right here. Okay, and we're rotating it around the x-axis. All right, so we're rotating it this way, right here. Okay, now, so we want that volume right there, and we know that this is going to be a washer because there's this hole that's going on right here that we've got to cut out. All right, if you ever want to know where they intersect, this one's not bad to just graph and figure out where they intersect, but if you ever want to know where they intersect, set these equal to one another. All right, and when I do that, I would have to square that side, so that becomes x equals x to the 4th. When I move that over, it's x to the 4th minus x, and here I would factor out an x, so it's x cubed minus 1. And here x equals 0, so they intersect at x equals 0, and then here when I take x cubed minus 1 and set that equals 0, I get x equals 1. All right, so they intersect at 0 and 1. All right, and that's going to be my bounds for my integral from 0 to 1. So when I do my integral, I've got to do this right here. All right, and since I'm rotating around the x-axis, I want everything in terms of x, so I'm good there. Okay, so here I'm rotating it around the big axis. So I want to do the top minus the axis of rotation Okay, so the big R is actually the square root of x minus 0. And then little r, okay, the x squared's on the bottom is going to be x squared minus 0. All right, obviously we don't need the zeros, so here, now think about when I square it, that means r squared is going to be x, and that means little r squared is going to be x to the 4th. All right, so it's going to be x minus x to the 4th, like this. And I still need the pi like I did yesterday for the disk. All right, now when I go to integrate, it's going to be pi, all right, x squared over 2 minus x to the 5th over 5, and I'm doing this from 0 to 1. All right, when I plug 1 in, I get 1/2 minus 1/5. All right, I don't really need to put 0 in. Okay, here if I want to change it, let's see, that's going to be pi. If I change it, that's 5/10 minus 2/10. All right, so I end up with 3 pi over 10 as my final answer. All right, so let's do this again. Number 2. The volume formed by a region rotated by y equals x and y equals x squared. Now, we could sit here and graph this if we want, or we can set these equal to find where they intersect. All right, here I know the line y equals x does something like this. All right, y equals x squared. Okay, we just did that. That's at 0, and then it's at 1 right here, 1, 1. So it comes up like this. All right, so it's this region right here. Kind of looks very, very similar, and I'm rotating it around the x-axis. So it's doing, we're basically doing something like this when it rotates. All right, so here we go. We know it's from 0 to 1 because that's where they intersect, and if you want to set those equal, you're welcome to. Okay, well, let's think about this for a second. Big R. Okay, it's going to be the top minus the bottom, and it's really the top, okay, which is this line right here, which is x, minus the axis of rotation. And then the bottom would be x squared minus the rotation. Now, when I go to square these, this makes x squared, and when I go to square this, it makes x to the 4th. So this is going to be x squared minus x to the 4th dx. Don't forget your dx, or obviously they'll count off. All right, so here, let's go integrate this. So pi is going to be x to the 3rd over 3 minus x to the 5th over 5, and I'm doing this from 0 to 1. All right, let's plug 1 in. So this is 1/3 minus 1/5. I'm going to do the same thing. I'm going to come up with a common denominator. Say this is without a calculator. You got to be able to do it without a calculator. Okay, so that's going to be 5/15 minus 3/15, and I end up with 2 pi over 15. So the volume of that is going to be 2 pi over 15. Okay, not so bad right now. Let's look at number 3. The volume of the solid formed by x equals y squared and x equals y cubed from y equals 0 to y equals 1 revolved about the y-axis. So this one time we're revolving it about the y-axis. Here, notice that what we've got as far as it's x equals. All right, here if I take the square root of this, it's the line, it's like the square root of x. So it goes like this. And I could actually do the other side because it would also be the negative. All right, here, if I did the cube root, if I graph this, I like to graph it when it's in terms of x. Okay, 0, 0, okay, but 1 is going to be right here. All right. I might want to look at it on a graph a little bit. It ends up, what happens is, it ends up that this one's on top. The y cubed is on top and the y squared's on bottom. All right, so here we go. Big R is going to be the top, which is y cubed minus the axis of rotation. Little r is going to be y squared minus the axis of rotation. All right. Now, when I go to square it, that's just going to be y to the 6th. This is going to be y to the 4th. All right, so let's set up our integral. It's from 0 to 1. Okay, this is in terms of y, so y to the 6th minus y to the 4th dy. And notice I put, this is the y-axis right here. And they actually gave it to us in the problem, so we didn't actually have to find it or pick it out. All right, let's integrate. So it's y to the 7th over 7 minus y to the 5th over 5. Okay, and we're doing it from 0 to 1. I'll let you simplify that. The final answer should come out to be 2 pi over 35 if you're doing it exact. All right, number 4. We want to find the volume of the solid of the area formed by y equals x squared and y equals 4x as it's revolved around y equals -2. Okay, so -2 would be right here. So we're revolving it around this. All right, y equals x squared. Okay, 0, 0, 1, 1, 2. Okay, so this is going something like that. All right, y equals 4x. So 0 at 1, it's at 4. All right, and if we want to find the intersection, I might want to just set x squared equal to 4x. So x squared minus 4x equals 0. So x, and then x minus 4. I end up with x equals 0 and x equals 4. All right, so these are going to be my bounds when I set it up. All right, and what's happening is I have this line and I've got this figure right here. Well, what's on top is the straight line, the 4x. Okay, so the big R is going to be the 4x, and it's minus the axis of rotation. I want you to notice this is -2, so minus -2. All right, well, guess what? That changes to a plus. Okay, little r is going to be the x squared minus the -2 as well. So again, this turns to a plus. Now, when I go to square this, I don't really want to multiply it out, and I'm just setting up the integral anyway. So I needed the pi. I'm doing it from 0 to 4. That's where they intersect at. All right. I am doing it in terms of x because I'm rotating it around something that's parallel to the x-axis. All right, so I leave this as x, and this is going to be 4x plus 2 squared, because remember you're doing big R squared, minus, all right, now you're doing little r squared. It's x squared plus 2 squared. I'm going to close the bracket, and then I'm going to do dx. Be careful of your brackets. Be careful of your parentheses. You do need to put the entire thing into brackets. Now, it just says set up the integral, and several FRQs could do this on the AP exam, that you just set up an integral and leave it. So make sure you know how to set up the integral. All right, number 5. Okay, we want to do the volume of y equals 6 minus x, y equals 0, y equals 4, x equals 0, rotated about the x equals 6. So let's draw that out, and I'm actually going to use this axis that I have here. x equals 6 is this. So I'm rotating about something that's parallel to the y-axis. So therefore, I've got to put this in terms of y. Y has got to be in my integral. Okay? I'm doing it from y equals 0, which is this right here, to y equals 4. Okay, x equals 0 is this. All right, and this is the line. Now, I'm going to draw the line in here, but I'm going to have to solve this for x in just a second. Here, it hits at 6, and it's down 1 over 1 in the negative direction. Okay, and I'm taking this shape right here, and I'm rotating it about this line, x equals 6. So therefore, what's happening is I've got this shape right here, and I'm revolving it, and look, it doesn't touch this entire axis right here, so therefore it's a washer. All right, so here we go. I've got to put this in terms of y. So here we go. If y equals 6 minus x, y minus 6 equals negative x. And so I end up with 6 minus y equals x. All right. So here's this line right here. Now, anytime I put it in terms of y, I'm going from my right to my left. Okay. Or I'm really, if you want to think of it this way, I'm doing the big radius right here. Okay, the big radius is going to be from this line to that line right there. And then the small radius is going to be from your line here to the axis of rotation. Okay. Now, but again, I'm doing it from right to left. So I'm going from, this time I'm doing the axis of rotation, which is 6, minus this line right here, which is 0. So here, r squared is just going to be 36. Okay, little r, I'm doing it from right to left, so I'm doing the axis of rotation first, minus this line right here, okay, which is 6 minus y. Okay, if I clean that up, that makes just y. And so therefore, when I do little r squared, it's going to be y squared. Okay, so let's set up that integral. It's going to be pi. From my y's, I'm doing it from 0 to 4. Okay, and I'm doing 36 minus y squared. I've already squared them, so I don't need to worry about squaring them. And then put dy. So if I was just to set up an integral, it would be that way. All right, now I want to integrate. So I end up with pi 36y minus y cubed over 3, and I'm doing this from 0 to 4. I'll let you go plug the 4 in. You don't necessarily need to plug the 0 in. And when you simplify this, this makes 368 pi over 3. All right, let's look at number 6. So that was not about the x-axis or y-axis. All right, and notice that in number 5 we hit the rotation of an axis first. All right, here we go. This time we're doing it around y equals the square root of x. So let me just kind of graph this. All right, it's that line right here. Okay, x equals 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And we know when we plug this in, x equals the square root of 9, it hits at 3 up here. Okay, and it's rotated around x equals negative 1. So we're rotating it around this line right here. So I'm rotating it around something that is and it says the x-axis. So here, when I color it in, here's my figure right here. And if I'm rotating it around the x equals -1, there's going to be a washer because there's going to be a hole. All right. Here I needed terms of y, so what I'm going to have to do here is I'm going to have to solve for x. And when I do that, when I square each side, I get x equals y squared. I notice that my bounds are from, on the y-axis, I can go from 0 to 3. Now, big R. Because I'm using y's, I'm going from here. My big radius would be this right here. So what do I hit first? I hit x equals 9 minus, what do I hit last? The -1, the axis of rotation. So that equals 10. So the r squared equals 100. Now little r. Okay, little r is coming from here. Okay, it's coming from this equation right here, which is y squared. And then minus, I hit the axis of rotation, which is -1. Now, when I square r squared, I'm just going to do y squared plus 1 all squared like that. All right, so I'm doing 100 minus y squared plus 1 squared. I'm going to put brackets around this, dy. All right, if I actually if I square that out, it's y to the 4th plus 2y squared plus 1 dy, and then I would have to change my signs. When I change my signs, I end up with a -1 here, so that's going to be 99 minus y to the 4th minus 2y squared. All right, and I will let you integrate that from there. You end up with 1,152 pi over 5. If it's a calculator one, then all you have to do is plug it in your calculator. Just don't forget the pi, guys, when you're doing the volumes. If all you had to do was set up the integral, it would be okay just to leave it like this. Okay, don't even try to square that out. All right, and one last problem. Okay, I want to do the volume, x equals y squared. It's rotated about x equals 6, so it's rotated about this line, parallel to the y-axis, so I do want it in terms of y. All right, now, for graphing purposes, let's see, I want x equals 4. So here's x equals 4 right here. All right. Now, when I set these equal, all right, I realize y equals 2. All right, and here, that's that equation right there. But then also you got to do the negative of it. So it actually comes down here. So I'm taking all of this, and I have to, since it says stopped at from basically this equation to x equals 4, I have to stop it there. And I rotate it around this line right here. Now, because it's parallel to the y-axis, all right, I need to put everything in terms of y. All right, that also means that the bounds are from the y-axis as well. And if you notice, this y is -2 and this y is 2. So those are my bounds. Okay, now I've got to figure out what big R and little r are. Big R, think about going right to left. I actually hit the axis of rotation first, which is 6, minus, and the big axis, I'm hitting the equation y squared. Okay, so when I do r squared, it's just going to be 6 minus y squared squared. All right, little r, okay, is this right here. Basically, I hit the axis of rotation, which is 6, minus, and then I hit this line, y equals 4. So really, that equals 2. So little r squared is just going to be 4. So when I do the integral, I'm doing it, and I already started it over here. I need to do big R, which is 6 minus y squared, squared, okay, minus 4. And then it's dy. I'm going to put my brackets in here. if you want to go ahead and, if you're doing this by hand and you want to square this out, all right, we end up with, and I'm going to square this out over here, we get 36 minus 12y squared plus y to the 4th. All right, and I ultimately subtract the 4 from that. So that's going to be 32 minus 12y squared plus y to the 4th dy. I'll let you integrate that by hand just to get practice by hand. Notice this is negative 2 to 2, so it will be a little tougher. The final answer is 384 pi over 5. All right, so you've seen disc and you've seen washers. Washers, there's a hole, okay, and the whole thing doesn't touch the axis of rotation. A disc, your whole area touches that axis of rotation. So those are the two differences between the two.